This lecture covers table relationship and diagrams. And this is where we are in relationship to our course objectives. We are still working on table modeling. In previous section, we learned how to determine the tables and entities. And then the next steps are step 1, determine if a direct relationship exists and if you want to track it. Step 2, determine the type of a relationship, and step 3, modify the tables according to the relationship type and the corresponding rule. Then we diagram the relationship. Step 1, is there a direct relationship between the tables? To help you determine whether there's a direct relationship, try this. Create a sentence using a verb that shows the possible relationship between the two tables, and then consider the sentence in the verb and ask yourself, does it describe something the organizations want to track? This is an example. Let's take two entities, mother and child. And here are two possible sentences that you might come up with. The first one is a mother feeds a child. So this could be a mother nursing a child, for example. And perhaps we're doing a study and we want the mothers to track when they nurse a child, and we'll record that information. In that case, feeds is the verb. We then ask ourselves, is that something we want to track? Now, something very different is a mother bears a child. Perhaps a mother is in the hospital and she's giving birth to a baby. And we want to track the event, so when you focus on the verb, it focuses on what you want to track. And you ask yourself, is that something the organization wants to track? Here's another example of students in classes. You could have a student register for a class, but you might also have a student complete a class. These are two different things, you know. When a student registers for a class, it doesn't mean that they have already completed. They have simply registered for a class, and that might happen many times in contrast. It could be that you'd want to track when a student completes a class. A student might register for a class several times before they were actually able to complete the class. And maybe we want to track that, or maybe the organization only cares about whether the student completes a class. So again, a helpful tip is to write down a sentence with a verb connecting the entities that helps everyone focus on what they want to track between those entities. Step 2, which is where we determine the type of a relationship, which is also known as cardinality. So in early section, we covered the types of relationships, one-to-one, one-to-many, which is the most common, and many-to-many. Here's a technique you can use to determine a relationship between two entities. We have two tables, here mother and child, and we will come up with the sentence down at the bottom, a mother bears a child. So we will determine that there is a direct relationship and it is something we want to track. We can now put the relationship side by side and we write the number 1 next to the first entity. We say for one record in the mother table, how many related records could there be in the child's table? And the answer is one mother could bear many children. Then we go in the other direction. We always write a 1 on that side, and we say for that one record in the child table, how many biological mothers could there be? One or many? And the answer is only one at this point, unless you want to get into some more complicated genetic things. But we will keep this simple. So for one child, there could be only one biological mother. If there's an N for many, the N always wins. Otherwise, it's just one. So in the mother column, it is all the ones that becomes one. In the child column, there's an N, so that N overrides 1. So this is a one-to-many relationship. In this relationship, the matter table is the one table and the child table is the many table. Let's try another example. Here are students and instruments. And we have a sentence down below and it says a student is loaned an instrument. Perhaps this is a school that they have an instrument loan program. Students can sign up for music class and then they can rent instrument. Again, starting from the left hand side. We type and write one number, enter student, and we say for one student, how many instruments could there be in one or many? And the answer is many. One student may start off with the violin, but after that, they may switch back to some other instrument. Now we go back in the other direction. We write a 1 on this column and we say for one instrument, how many related records could there be, one or many? And the answer is many. Over time, the instrument like a tuba might be loaned out to several different students. So in this case, it's a many-to-many relationship. And the ends always override 1. Here's another example, category and product. Think about this and maybe do this in your head or on a piece of paper. You start by writing 1 underneath category and you ask for one category, how many related products could there be? And then you go in the other direction for one product, how many related categories could there be? We have a sentence down below which is product belongs to a category. For example, milk belongs to dairy category. Think about it. Alright, now you have some time to think about it. Is it a one-to-many or is it many-to-many relationship? And the answer is it depends on the business rules. Some organizations may categorize a product in only one category, and some other organizations may categorize a product into more than one category. It really depends on the business rules. When we do relational database design, we follow the theoretical rules, but we also adhere to the business rules of the organization. And these business rules affect how we interpret some of the theoretical rules. So how do you keep track of all these relationships between tables? Well, a matrix may help. Ask the question, can a single record in one table be directly associated with one or many records in the second table? If there's no relationship, you leave the intersection cell blank. So let's take a look at a real spreadsheet where I did. So in here, I've got matrix between buildings, classes, these entities, buildings, classes, faculty, and students. And then we have the same entities forming our columns. So it's redundant to have anything between buildings and buildings, but for one building can provide space for many classes. And then if you look at it from the class side, a single class is held only in one building, and we say there's no relationship between buildings and faculty and buildings and students. We go down here to classes. A single class can be taught by many faculty members, and a single class can have many students in it. And if we go down to faculty can teach many classes, and students can take many classes too. So if you do what we talked about in the lecture, you're going to see there's a one-to-many relationship between buildings and classes, and there's a many-to-many relationship between faculty and classes, and there's also a many-to-many relationship between students and classes. Again, step 1 is determining if there's a direct relationship. Step 2 is determining what kind of a relationship it is, and step 3 is the step in which we modify the tables according to the relationship type and corresponding rules, and then we diagram the relationship. Firstly, a little bit of review. Here are the types of relationships: one-to-one, one-to-many, and many-to-many. Now, the most common relationship we're going to see is one-to-many. So we'll cover that first in the one-to-many relationship. The primary key field from one table should appear in the many table as a foreign key. Here's an example. We have two entities, buildings and rooms. We've determined that it's a one-to-many relationship. One building can have many rooms, and for one room, there's only one building. So the rule is the primary key from the one table should also appear in the many table. The primary key from the one table, which is buildings, the primary key is building number, and it appears over here in the rooms table, where it is also labeled as a foreign key. So again, primary key from one table must also appear in the many table. Now let's take a look at the rule for many-to-many relationships. And in many-to-many relationships, it's a little bit different. The rules is the table needs to be created, and then the primary key fields from each of the one tables should appear in the junction table. Now, sometimes when you create a third junction table, you have trouble thinking of a name for it. We need to create. You should call this a student instruments table. That's probably the most common way of naming the junction table. Just to combine the two names of the one side of the relationship, and then the primary key from each of these tables ends up in the junction table as foreign keys. So if you look at the crow's feet notation, the many symbol looks like a crow's foot. In this many-to-many relationship, it's one-to-many into the junction table. When you have a many-to-many relationship, you have to create a third junction table, and the relationship between it is one-to-many and one-to-many. The last one we're going to cover real brief is one-to-one. It's not as common, and in this case, everybody who is employed at Beverly College is either a staff or a faculty member. Faculty members have some characteristics that the other staff people don't have, like are they tenured or not, and like their title. Not as common, so our ultimate goal is to have completed entity relationship diagram, but you are just by doing relationships between each of the tables, and then eventually you'll end up with something like this.